All right, you guys, so I am going to go ahead and break problems 50 to 52 down. So you do have to print the 7.1.4 resource page, which is linked in the calendar. And the first part is problem 50, and they want you to actually find the length of all of these triangles. So for example, that length, and then this one, this one, this one. So in order to do that, what we should have gathered from the last lesson is that the length of the triangle from the x-axis is actually just the cosine. So you can use your calculator to find all of these lengths of the distance from the origin to that end of the triangle. And of course, you can pause this to catch up with me, but I'm going to go ahead and start putting in all of these lengths again. So how I'm getting that is the cosine of 15 degrees, and then the next would be the cosine of 30. So I'm going to go ahead and start entering these. And so of course you can pause this at any time. And we know that this length is not 1, so it's actually 0. Since we're finding the this distance right here, and there's no distance, it's just 0. So the other thing that you should have learned, and we talked about last week, is all of these are just going to reflect. So I'll do my best to draw these in. Okay, so remember these are every 15 degrees. So we have 105, 120, 135, 150, 165, and 180. And we keep going. However, all of these are now going to be negative because we're talking about the x-axis in quadrant 2. And how I'm getting these so quickly is we're just reflecting across. So we know they're all going to be the same, kind of running out of room, and -1. And then you do the same thing. All right, so again, this is every 15 degrees. So 195, 210, 225, 240, 255, and 270. And again, all of these are going to be negative because we're talking about quadrant 3, and the x-axis in quadrant 3 is negative. And this will again be 0 because we have no horizontal distance. And then draw in your 5 lines. Hopefully yours looks better than mine. So we are reflecting, but in this case, these are all positive because we're in quadrant 4. So we know in quadrant 4 the x-axis is positive, and I should probably do my degrees first. $315, $330, $345, and obviously this is $360. And now we have 0.26, 0.5, 0.71, 0.8797, and then 1. Okay, so what we're going to do next is graph this, and I'm just going to kind of graph like the general equation, so I'm not going to worry too much about the details. So we know that this would be 1, 90 is 0, 180 would be -1, 270 would be 0, and 360 would be 1. Okay, so from here, we are going to kind of miss that, but it's good enough. All right, so it's going to look something like this. And so just making sure. All right, so we are also going to do what we did last week in class, by identifying like the domain and range and all of those attributes of the graph. So the domain is going to be the same as the sine graph, which is negative infinity to infinity. In other words, all real numbers. The range is also the same as sine, so it could be as low as -1, as high as 1, but keep in mind this is just for the parent graph, so when we start doing transformations, that will change. And then we have the x-intercept and the y-intercept. So the y-intercept is going to be 0, 1, whereas sine is 0, 0. And then the x-intercept is also going to be different from sine. So it's 90 plus 180 n, and then from there 0. So what that means is it starts at 90 and then we're going up by 100 every 180 degrees. It will touch the x-axis, and of course once we start doing transformations this will change. Okay, so all of that is for problem 50, and then I'm going to just kind of scroll down and do the next problems below. So we have 51. So they're going to go back to the lovely Ferris wheel question. So what it's talking about is this time LaRasha. So she is sitting 27 horizontal feet away from the central support pole. So I'm just kind of visualizing that. So let's say we have here, and then we know that this is 27 feet. And so what we want to know is what was her angle. So what we're going to have to do in order to do this is we're going to use inverse cosine. So we have to do cosine -1. So that's actually a button on your graphing calculator. So you do second cosine, which will give you cosine inverse. And we're not doing 27 because remember that's actually 0.27 in terms of the unit circle. And this will give us approximately 74.3. Okay, so then that means that the angle that she was at was 74.3. The next question they're asking, is there more than one possibility? Well, of course, because we also know that we can have this right here, or that, or that. So kind of going back to that bow tie, so we can have that angle, and that angle. So how we get those is those are, again, kind of like our reference angles. So we can do 180 minus 74.3, and that will give us 105.7 degrees. Okay, and then we could also do 180 plus 74.3 degrees, and that would give us 254.3 degrees. And so I just found this angle right here and that angle. Now to find this last one, I would do 360 minus 74.3, and that would give us 285.7. So although those are all different angles, they all have the same reference angle, and so they would all actually yield that same cosine value. All right, next is 52. So for problem 52, it wants you to look back at the resource page. So we didn't need to print that one, but it's talking about really essentially just finding the cosine of 130 degrees. So we want to find the cosine of 130 degrees. When you do that, you should get something like negative 0.64. And so it's asking you to find the length of that distance. So it means that that seat is actually 64 feet left of the center, and that's why it's negative. And so that would be for part A. And then for part B, it's asking, are there any other triangles with the same base? So again, of course there are. There's going to be 3 other ones. So for 130, we're going to kind of sketch that in. So 130 is right here. Okay, so we know that this is 130, this right here is 180, and this is 50 degrees. So I would also have of course, this angle right here, and this angle right here, and this one. So one of the angles would be 50. One of them would be 180 plus 50, which would be for right here, and one of them would be 360 minus 50. And so that would give you all of those angles. And so those would be 50 degrees. And then the 180 plus 50 would be 230 degrees. And then the 360 minus 50 would be 310. All right, and last part is part C. It says, how can you use the symmetry of the cosine calculator graph to calculate the angle location of the seats on the screamer that have the same base? Is your method different from the one you used to find the heights? So what you should gather is the graph is symmetrical across the line y equals, actually I should say the line x equals 180 degrees. All right, and that is it.